Hello everyone and welcome to this course on the history and culture of chemistry. First, I would like to introduce myself. My name is Juan Fernando Gómez-Pérez and currently I'm working at the University of Szeged at the Department of Applied and Environmental Chemistry. I have finished my PhD studies last year at the same institute, and since then I have been working like a postdoc. My field of research is on two-dimensional material, specifically called phosphorine, which is an allotrope of phosphorus called black phosphorus. And additionally, I work with nanostructures for heterogeneous catalysis, more specifically for CO2 reduction. Previously, I have been teaching at universities in Colombia and here at the University of Szeged as well, covering different topics like water treatment, global warming, environmental impact assessment, general chemistry, among others. About the course of History and Culture of Chemistry. This is the second time I will be giving this course and the first time online. On the topics, we will cover different periods of history, starting from the Neolithic period, more specifically starting at the so-called Neolithic Revolution, and we will go so far as the discovery of electrons and the development of nuclear bombs. During these topics, we won't focus only on the chemists and the persons who develop new technologies or new discoveries, but we will also cover the context on which other people could impact the history of chemistry. One of the greatest examples is with Alexander the Great, which, without being a chemist himself, had a huge impact on the history of chemistry. So thank you so much for registering this semester, and I hope you enjoyed. This semester we will cover the 12 topics listed on the table to the left, and the study material will be posted in the course page altogether with some supporting information, references, and videos. More important, the topics won't be covered exclusively by myself, but it requires your active participation and work. That's why on the table you will find that every week uh, one oral presentation 20 minutes long will be shown or given by the students. The number, what you see on the table to the left, belongs to one student, and that student is listed to the right. So, for example, next week we will talk about the classic Greek philosophers, and the student Camille will have to give an oral presentation 20 minutes long on a subtopic related to this field. He could choose, for example, one of the Greek philosophers and develop his ideas and theories, or he could choose something about the context in the ancient Greece that could help us to understand how this environment could uh, be related with the development of chemistry. Next week, after him, there will be a topic of alchemy, which I will prepare a supporting material, a video like this one, and additionally, we will get the presentation from Fernando Casian, and so on. So at the end of the semester, you will have around, you will have 3 presentations like this and some grades from additional activities I will be posting online, like for example, some exercises, some homeworks, some text you have to write, or some short exams or evaluations online. As a reference textbook, I propose you to check the book from Isaac Asimov titled Short History of Chemistry from 1965. Okay, so let us start with the first session. This week, we will focus on the developments of the ancients. And as I said before, we will start from the Neolithic period and the Neolithic Revolution, and we will continue to the development of the first cities, and we will go through the development of natural sciences, more specifically on metallurgy and what is so-called the Bronze Age, the Iron Age, and so on. So what we can see from this study, from this parallelism, is the development of natural sciences brings forward the development of human civilization. And if we talk about civilization, there are there is a region in the world where we can say that the human civilization started. And this is with the formation and development of the first cities by the Sumerian and Akkadian cultures. So in CoSpace, you will find some supporting information where you can take an image of the context of the Sumerian and Akkadian cultures from its rise to its collapse. But before we start to discuss about the different periods in human history, like the Bronze Age and Iron Age and Sumerian cities and so on, I would like to stop a little bit about the human evolution itself. What we know is that early humans were completely dependent on the cycles of nature, and so was their approach to nature. First, their tools were taken directly from their surroundings as they found it, and it took millennia so humans learned how to shape rocks and get cutting edges and gripping. Nevertheless, during these early periods, no chemical change was done to materials from nature, despite the fact that these natural or these chemical changes took place naturally, like for example in process of lightning that could set fires, or organic matter decomposition that changed the smell and taste of foods and so on. We can say that human evolution is a long process starting around 7 million years ago with the development or with the evolution towards bipedalism. If we compare how is this motion in quantitative terms between humans today and bipedal or quadrupedal chimpanzees, we can say that human walking costs around 75% less energy than the other cases. Evolution also had a significant impact on brain volume. For comparison, Australopithecus afarensis had an estimated brain volume of 500 milliliters, while Homo erectus reached 1000 milliliters, and finally, with evolution towards Homo sapiens, we know it reaches around 1250 milliliters. In comparison with other primates, the average encephalization quotient, which is the relation between the actual or expected brain mass of brain per body weight, is between 2 and 3.5 for primates and early humans, while for the humans currently is between 7.4 and 7.8. It shows a significant difference in the brain volume related to the body weight, and it could be explained by different factors, including the change in diet. And this is important because this is directly related with probably the first invention of humans, which separate us from other species in the world, which is the ability to set and maintain a fire. This fire could bring changes in our diets, but also in the materials and in the tools we use. So we see also that from human evolution is evident how the complexity of the tools grew. For example, some stones have been found from periods, stone tools have been found from periods of 3.5 million years ago, while multi-component tools were used only 500,000 years ago. So we see that the first process of human and technological advances took place very slowly in human history. And we should consider that the first Homo sapiens appeared around 190,000 years ago. And what we will cover during this semester is precisely the developments and advances in the field of natural sciences by the Homo sapiens until today. In the figure to the right, you can find a diagram showing how was the estimated human evolution from the early apes, which appeared around 10 million years ago, to the modern humans. and the Homo sapiens around 500,000 years ago. And as I said, probably the most important development of the time was the ability to start and set the fire, because, as I said, it could bring opportunities for cooking, pottery, and environmental management. What we can see from the right figure is that this ability to set fire, it comes around 1.5 million years ago, when still was on Earth the Homo erectus, and this brought developments on the human itself in biological sense. As a side note, I also would like to share a recent publication from 2018 in the Journal of Royal Society, where Barrett et al. Claims that a group of primates in Panama may have started the Stone Age, and they define so by their social abilities to develop tools and to teach to their mm, family members, and it's interesting to see it alive. At the end of the Stone Age, around approximately 8,000 to 9,000 years ago, the first revolution started in what today is known as the Middle East. These societies started to develop techniques to reach a more reliable food supply through animal husbandry and agriculture. Especially agriculture required people to stay in one place, so permanent buildings were constructed and the first cities started to grow. Here we should highlight the region of Mesopotamia between the rivers Tigris and Euphrates, extending from the Persian Gulf to the mountains in the Kurdistan region in Iraq and Turkey. In this context, we can say the development of agriculture is the beginning of human civilization, as the word itself comes from the Latin term for city. The greater stability of food supply supported population growth, which in turn supported expanding agriculture. For context, from a study of 340 foraging societies, which is characteristic of nomadic life, it was concluded that these populations have an average density of 25 people per 100 square kilometers, which is too low to support complex societies and even lower than massive herbivores. From another perspective, we could say that the development of agriculture is an attempt for the domination of nature. In this new scenario, humans no longer depend on natural cycles, but they could modify their environment to allow the development of larger populations. The first societies, the first cities were characterized not only for the larger populations but for their complexity. New specialized workers were characteristic of complex societies, and the first advances in science took place in diverse fields like astronomy, physics, arts, mathematics, and so on. Some of the advances of the first Sumerian cities persist until today, like the sexagesimal system used today for the division of times into periods of 60 minutes per hour, which is not the common system used today in other fields of science we use. Like nowadays, we are based more in a decimal system. One of the first cities in history was Uruk, located in Mesopotamia, today Iraq. Mm, Even though before Uruk, other societies were also recorded, but it is believed that Uruk is the first city because it was the first walled city. Even there are poems written at the time about their walls. Uh, and according to some archaeologists, this is one of the parameters to define a city at the time. Certainly, Uruk was one of the most important Sumerian cities, if not the most. Other important cities at the time were Kish, Ur, among others. The city of Uruk flourished approximately 4,500 BC and reached a peak population of 8,000 inhabitants in the 2,800 BC. So we are talking about a city around 5,000 years ago with a population of half of Szeged, which is quite impressive. Another important development in Sumeria was the invention of the written system called cuneiforms, and later the first alphabet. When the cuneiforms were developed, it reached around 1,500 symbols for different objects. But when it grew in such complexity, it was necessary to switch from the representation of symbols or from the representation of objects and actions to the development of a system based on sounds. And this is the appearance of the first alphabet. The cuneiforms were invented around 3200 BC, and as I said, it reached around 1500 symbols. Written texts from date record details of the Sumerian and Akkadian cultures. Written text is fundamental. It was a fundamental advance to pass knowledge through generations and allow the sophistication and development of science. By the year 4000 BC, these characteristics of the Neolithic Revolution are found in Europe, but in Egypt and Sumeria, mankind began to learn how to use rare materials, metals, what we know like metals. The first metals must have been found in the form of copper or gold nuggets, and their first use was ornamental in the level of seashells or colored pebbles. However, some differences are known. Metals are malleable. They can be beaten flat without breaking. It was found that copper could easily be beaten into sharper edge than could be produced on a tool of stone, and once it was blunted, it could be sharpened again more easily than a stone edge could be produced. Only the rarity of copper prevented its widespread use for tools and ornaments. Around 4000 BC, then, most probably in the Sinai Peninsula or in the mountainous regions of Sumeria, today Iran, it was found that copper doesn't need to be found free, but it could be produced from specific rocks if placed on the fire. The precise location of and time of this discovery still unknown, but it could be by coincidence that starting a fire on a bed of bluish rocks containing copper minerals could produce copper in a free form that later could be manipulated to produce sharper edges and ornamental instruments. Later, with the popularization of copper, in an Egyptian tomb was found a special hard variety of copper, most likely produced by accident by the simultaneous heating of copper and tin ores to obtain what we call today like bronze. Bronze is harder than copper, and by 2000 BC it became common enough to produce weapons and armor. Again, several bronze artifacts have been discovered in Egyptian tombs from a period of about 3000 BC. The Trojan War is an example where soldiers were equipped with weapons and armor made of bronze that gave them an advantage over any other nation without this technology. This connection between metallurgy and politics gave the metal workers prestige in their societies, and even today we can see how the related names are among the most common names between European peoples. For example, in Spanish, the last name, family name Herrera, is directly related to this process, or Kovacs in Hungarian or Smith in English are among the most popular names in their countries. Sometimes this prestige went maybe too far, and for example, in Africa, strict sexual abstinence was usually mandated for all male iron makers during smelting, mining, and smithing, which could explain a less efficient knowledge transfer in those societies. Archaeological evidence demonstrates that metal workers from the Bronze Age also knew about the existence of iron and its superior properties over bronze. Unfortunately, it seemed to be too rare for them, as the only samples from early times were bits of shattered meteorites. The identification of meteoritic and terrestrial iron is done today by evaluating the nickel abundance or the nickel cobalt iron ratios, for example by techniques like XRF, X-ray fluorescence. In the CoSpace, I also uploaded a scientific paper about how to identify these irons from meteoritic origin or terrestrial origin. On the slide, you will find some examples of Bronze Age iron that are iron artifacts made during the Bronze Age and mainly from meteoritic origin, like small pieces for ornamental purposes or daggers, for example. About these artifacts in the manuscript, in the paper I told you before, you will find some details about their location and the examination to determine its origin. Even though metal workers from the Bronze Age knew about iron, the technology for iron smelting requires higher temperature and it was not available for them. A wood fire then is not sufficient for iron smelting, and charcoal is needed with an intense air supply. Iron in pure form is not very hard, but the iron-carbon alloy is harder than even the best bronze and holds a sharper edge longer. This is the alloy we call steel, and again it resulted in technological advantage in the battlefields. There is no consensus whether the Hittites had iron smelting or not. There is evidence they used iron for meteorites, and the number of objects is comparable with the ones found in Egypt. However, also exist pieces of evidence of iron production around 1300 BC in Hattusa, which is often referred by the name of modern town Bogaskoy next to it. Um, Hattusa was the capital of the Hittite Empire. The Hittites are interesting for several reasons. They built a mighty empire, but vanished from human memory already during the classic antiquity. Even early archaeologists who already knew plenty about the ancient Mesopotamian and Egyptian cultures had no clue or misread whatever there was about the Hittite empires. The existence of Hittites slowly became known at the end of the 19th century, and the turning point was the discovery of the royal archives in Hattusa by the German archaeologist Hugo Winkler. While written in the by then familiar cuneiform language or script, their language was unknown, but the same as the language used in some letters found in Egyptian royal archives in Amarna. An Austro-Hungarian scientist who was born in today Czech Republic, Bedřich Hrozný, figured out the language and made it common knowledge in 1917. Nobody knows where the Hittites came from and how they somehow crowded out the Hittite culture in Anatolia, starting around 1800 BC. Their language is of the Indo-Germanic type, while that of the uh, surrounding cultures it was different. That makes us sure that those cultures have different roots. Another important finding about this Hittite culture is that it makes a bridge between the ancient Mesopotamian cultures, so they use their cuneiform symbols, for example, but also the Hittites had this Indo-Germanic language, which is common to the European cultures, and most of or many of the knowledge, most of what we know about their culture and religion, it was transferred to late European cultures. Mm, Other civilizations that were equipped with good iron weapons in quantity and quality were, for example, the Assyrians, which was the first army to be fully equipped with this type of army material. Besides metallurgy, other chemical methods were advancing in Egypt and China and India mainly. These were related to the production of pigments and juices, so not only from geological substrates, but also from plants, for example, especially in Egypt, where embalming and preserving the human body was promoted by religious interest. And this connection between religion and chemistry is what later will give origin to alchemy. Alchemia. The original knowledge about the process of iron smelting still can be traced until today in some African communities. So there is an interesting work from Professor Dr. Schmidt and Dr. Avery at the Brown University, where they visit some African communities and ask them to build this type of smelters. And then you can find publications online about their discoveries and the techniques, how they did the iron smelting in those times. So we can say that the ancients were familiar with seven metals. They were gold, silver, mercury, copper, iron, tin, and lead. Additionally, they employed various preparations of zinc, antimony, and arsenic, though there is no evidence that they knew them in their metallic state. Okay, now I'm going to describe a little bit about each of these metals. So the first references to gold can be found in religious documents, like the chapter of the Genesis in the Bible and other religious books. From ancient books, it is clear that gold was more abundant on the surface of the earth and the beds of rivers in the early periods of society than today. This is also clear from the account of Pliny the Elder, who was a natural historian around the year 50 AD in the Roman Empire. He was, besides this, he was politician, he was a commander of the navy, and so on, several political and positions in the Roman Empire. He gives a numerous list of places in Asia, Greece, and other European countries where gold was found in his time. Gold was probably the first metal with which humans became acquainted. Uh, Similarly, silver was also known in ancient Egypt at least in the year 1850 BC. Silver, like gold, occurs very often in their metallic state. Uh, In ancient times, silver and gold had a nearer value among them than it is today. Partially it is explained because of the conquest of America and the great amounts of silver found in Mexico and Peru. Silver was easier to handle than gold, thus it is easier to produce common utensils made of silver than gold. Third, about copper, we can say that it occurs frequently in nature, and probably it was known as early as silver or gold. In their metallic state, copper is too soft to be made into cutting instruments, but the addition of tin increases the hardness. From Pliny the Elder, we know that there was a confusion about the differences between copper and brass. Remember that brass is an alloy between copper and zinc, and it again appeared like a confusion during the alchemy period. Another use of copper, it was for coins in the Roman Commonwealth under the Emperor Romulus. Iron was known in its oxide mineral form, and it was used for different purposes, not just armor, but also other uses like in medicine, for example. Iron, most commonly found as an oxide, is much more complicated to smelt. Therefore, there is these differences between the Bronze Age and Iron Age of around 2000 years. Interestingly, religious texts uh, from Moses' time, around 1300 and 1400 BC, describe the use of iron in ancient Egypt at a time when it was unknown in Greece. The Trojan War, described by Homer, represents the soldiers armed with bronze armors and weapons, while the Greek poet Hesiod informs us that the knowledge of iron smelting was brought to Greece from central Anatolia, which is a region what we discussed before related with the Hittite Empire. And this knowledge brought to Greece around 1430 BC. However, the equipment of soldiers at the Trojan War demonstrates that the iron smelting did not improve to the level of applying this material to common purposes. Tin was of lesser value than gold or silver, however less common. The Phoenicians traded this material from the north coast of today's Spain and south of Britain, and the Egyptians got their supply from the Phoenicians, who kept it like a secret and for trading, yeah, for commerce. Lead seems to be common in the ancient Egypt at the time of Moses, around 1400 BC. Much later in Roman times, lead was used for common uses like for pipes for water distribution, but the ores were located in Spain and Britain. Another use was in medicine as astringent in its oxides forms. In the case of mercury, it was commonly known in Pliny's time, but it is known that the time of its but it's not known the time of its discovery. It was obtained from a mineral called cinnabar from a county above Ephesus, which is the western coast of Anatolia. Sometimes it was used as medicine, however, Pliny advised against it for its poisonous danger. Antimony was known at the time of Pliny from a mineral called sulfide of antimony found among ores of silver. Ancients used this as a pigment for painting eyelashes, first in Asia, later in Greece, and much later in Spain with the Moors occupation. It was also used in medicine as astringent. Finally, arsenic. They were not acquainted with metallic arsenic, but they knew about the native yellow arsenic sulfides.